Yes, let's look at example number 2, which says calculate the enthalpy per unit mass of dry air of saturated mixture of air where air is B and water vapor, which is A, at 303 Kelvin and 1 atmosphere. The reference state is air and liquid water at the temperature of 273 Kelvin. That is our TO. The vapor pressure of water at this 303 is 4.24 kilopascal. The latent heat of vaporization at 273 Kelvin is, this is 2502.3 kilojoule per Kelvin. The average heat capacities between 273 and 303 are Cp for A 1.884 kilojoule per kg Kelvin and Cp for B 1.005 kilojoule per kg Kelvin. So how do we go about solving this problem? So we can say solution. Because the air vapor system is saturated, we can actually use this YS, which is for saturation. Absolute humidity, molar absolute humidity for saturation, which is P minus PA, which is equal to 4.24 all over 101.325 minus 4.24, which will give us 0.044 mole H2O all over mole air. Now, why do we use P to be 101? Because P is equal to 1 atmosphere as it is given. 1 atmosphere is the same as saying 101.325 kilopascal. Now, Yx is equal to 0.044 MA all over MB. And we know that this is 0.044. MA is 18, that is for water, all over for air 29, which will give us 0.0272 kilogram H2O all over kilogram dry air. Now we now put the formula for the enthalpy, which is HS prime, which is equal to Cp B, very important, in bracket B comes first, T minus TO plus YS into bracket CPA into bracket T minus TO plus lambda O. So that's what we have. Then if we solve this down, we should be able to get that our H prime X is equal to 1.005 bracket 303 minus 273 plus 0.0272 into bracket 1.884 bracket 303 minus 273, which is the reference temperature, plus 252.3. So if we solve this down, we'll get 99.75 kilojoule per kg dry air at 303 Kelvin and 1 atmosphere. So this is the answer to the problem. Please, if you like this, hit the subscribe button. Thank you and God bless you.